Hello everyone. In this video, I'm going to introduce to you a new symbol used in mathematics, the n factorial. The n factorial means the number of ways to arrange n distinct objects, and I'm going to show you with the following examples. Example 1. If there's just only one object here, then how many ways can you arrange it? There's just one way, and that's it. So, example number 1, we will have 1 factorial equals 1. Then what about two objects? For two objects, we can arrange it in two different ways. One is red and then yellow, and we can have yellow first and then red. So there are two ways to arrange two distinct objects. So we will have 2 factorial equals to 2. Now what about 3? For 3 things, if we have 3 distinct objects, then guess it, how many ways to arrange these 3 objects? So let's count it. Red first, yellow and green. There's 1. Red, yellow and green. And then I reverse these 2. Keep the first one being red. So we have red, green, yellow. Now we replace the first position with yellow, then this is a totally new arrangement, right? So we have yellow, red, and green. Yellow, red, and green. Reverse it, we have yellow, green, and red. Yellow, green, and red. Lastly, we put the green one in the front. And we start with red again. Green, red, yellow. Green, red, yellow. And then lastly, green, yellow, and red. So there are a total of 6 different ways to arrange these 3 objects. So we have 3 factorials equals 6. But then in general, how do we get this 6? My idea is like this. Consider there are just 2 objects and we want to add the third one. Actually, you can add the third one at the last position, in the middle, and in front, right? So as 2 objects, there's just only one object here. For the second object, you can place it on its right or on its left. So on top of the first object, for the second object onwards, you have the total number of ways to arrange by having the object multiplied to its object number. Say for example, if it's the second object, we have 2 different positions to place. And for the third object, we have 3 different positions. So in the end, you have this 2 factorial means for the first object, there's just only one way to arrange it. We multiply it by 2 from the first object's right or left. So as the third object here, these 3 factorials can also be obtained by starting from the first object, we have the second object placed, and also we have the new object, the third object placed on the right, in the middle, or on its left. Okay, so in general, we don't use so much coins to do the demonstration, and we can know in general the n factorials is to start from 1, we multiply all the object number up to the last one we placed. So it's more convenient to write it as descending order, like this. And this is what we call the n factorial. Okay? Based on this idea, we can rewrite this n factorial in different forms. So I'm going to introduce at least two forms. The first one, since we know n factorial is actually n times n minus 1, n minus 2, and then up to 1. Keep the first term, and for the second term onward till the end, what can you see? It is actually n minus 1 factorial, isn't it? It starts from n minus 1, multiply to one digit smaller, smaller, and smaller up to 1. So for the first property, we will have n factorial is n times n minus 1 factorial. Second, we can also rewrite n factorial as starting from n plus 1 factorial. What's n plus 1 factorial? N plus 1 factorial is to start with n plus 1, we multiply it to 1 unit smaller, 1 unit smaller, and so on up to 1. Similarly, you will see starting from the second term till the end is actually n factorial. So what do we need is to cancel out this n plus 1. Okay, so there are two different forms to write n factorial. Okay, now later on is necessary for us to include some ridiculous thing. We call it the 0 factorial. Starting from the beginning, we should note that n is the number of objects. There should be a positive integer number of objects, right? But later on, there are some formulas that need 0 factorial for convenience. And now we are going to define what 0 factorial is. Just like you invent a complex number based on the real numbers, we want to extend a little bit up to 0 factorial without changing the original idea of n factorial, starting from 1. Okay? There are two ways to define the 0 factorial. So let's go for it. The first one is something like to extend it by its idea. The idea is to arrange n different objects, right? So if we imagine there is a 0 object here, there is 0 objects, that means there's nothing here, and I'm going to ask you to arrange it. And you are asked to find the number of ways to arrange the 0 object. There's just only one way to arrange it, and that is you do not need to do anything. So we can define 0 factorial to be 1. It's a little bit ridiculous, but then it's still okay to say that you arrange 0 object and the number of way is 1. Okay. Second way is to look for pattern. In mathematics, we start to look for patterns to extend our idea. Say for an example, how do we know the product of two negative numbers is positive? We start from something like this. Do you still remember? We know negative 2 times 2 is negative 4. We know negative 2 times 1 is negative 2. We know negative 2 times 0 is 0. And then you are asked to find the result by reading the pattern, right? And then you know the result is positive 2. So by deriving the pattern, we extend our idea from usual positive integer factorial to 0 factorial. Let's start with 3 factorial first. 3 factorial is 1 times 2 times 3. 2 factorial is 1 times 2. 1 factorial is just 1, right? And then you're asked to define or find what it is. To find the pattern, what you can see here, the 3 is missing. For the missing 3, we can say we can find it by dividing 3. Similarly, I can take out the 2 by dividing 2. So, in the end, we can say I can take out 1 by dividing 1. So, 0 factorial is defined to be 1. Okay? That's all for it. Thanks for watching.